Okay, so this is going to be before chapter 12.1, but we need to do this review with radicals and rationalizing the denominator so that you're able to properly notate your trigonometric functions of sine, cosine, and tangent. So we've got the square root of 4 times the square root of 4, which equals the square root of 16, which equals 4. You're going to be looking for a pattern so that we can eliminate this middle step. Okay, so we've got square root of 13 times the square root of 13, which is the square root of 169, which is 13. Square root of 6 times the square root of 6 is the square root of 36, which is 6. Now, see if you can decide what the pattern is. I'll tell you what it is in just a minute, but see if you can figure it out. Look for a pattern. Hopefully you notice that underneath these radical symbols matches that exact amount. So the square root of 4 times the square root of 4, the 4 is your amount. All right, now, so on the square root of 14 times the square root of 14, go ahead and write what you think this is and what it equals. Square root of 14 times the square root of 14 is the square root of 196, but we're trying to eliminate that step. It would be 14. Again, do the last one, but without the middle step. Let's do it without the middle step. Just write your answer. And then we'll go ahead and check it, but let's just highlight this. There's your 14, there's your 14, there's your answer. And hopefully with this introduction you were able to remember that when you take the square root of 36 times the square root of 36, yes, there is a middle step. We are going to, however, skip that middle step, and we're just going to simply write that it is 36. So again, 36, 36 is 36. Now you're going to use that when you're going to use those ideas when you rationalize the denominator. So we've got the square root, in A we've got 3 over the square root of 10. Well, you can never have a radical symbol in the denominator. So in order to not have a radical symbol in the denominator, you have to take the square root of 10 times the square root of 10, which will give you 10. Square root of 100 is what it comes out to. That gives you 10. Whatever you do to the denominator, you must also do to the numerator. So it's 3 times the square root of 10 over 10. You do have to look to see whether or not the 3 and the 10 can be simplified. They can't. 3 over 10 is the simplest form. So that is the final answer on that rationalization of the denominator. Okay, let's do one more of these. Square root of 23, 5 over the square root of 23. You can't have a denominator with a radical symbol. And so you need to multiply the denominator by the square root of 23, which will equal 23. Whatever you do to the denominator, you also need to do to the numerator. So it's 5 the square root of 23. And again, you're looking at this 5 and this 23 to see if it can be simplified. It can't. So this is the simplest form of that rationalized radical expression. Again, we've now eliminated the radical symbol in the denominator. I'd like for you to try out letter C. See what you come up with. Don't forget to check and see if you can simplify. As soon as you've finished it, turn the recording back on and see how you did. In order to get rid of the square root of 15 in the denominator, that radical symbol, you multiply the denominator by a square root of 15, which gives you 15. Whatever you do to the numerator in the property of equality, you must also do to the numerator. So you take 6 times the square root of 15. Now, however, when you look at 6 and 15, you can see that they have a common factor of 3. 6 divided by 3 is 2. 15 divided by 3 is 5. And so you end up with 2 times the square root of 15 over 5. Now you have to make sure you write these in the simplest form possible. Okay, now we're going to go on to an actual picture. So this is how it gets used in trigonometry. We'll do more with this, but it's good to just connect it right now. So you have a right triangle, because this is right triangle trigonometry that you'll be doing in chapter 12. And in this picture, you have a hypotenuse that you don't know at this point. You have your theta. That's what this little symbol is called. This is theta. And theta is the acute angle of the trigonometric function. That's what it means. And you've got the opposite, the angle, the side opposite theta is 3, so that's your opposite side. The side next to it, or your adjacent side, is 8. You don't know your hypotenuse. Now, typically, the adjacent side, which will be your x value on a coordinate graph, will be your a, but it doesn't really matter. So you're going to have 8 squared. And then your y, or opposite, will be your b usually. So 3 squared equals c squared. 64 is 8 squared, 8 times 8. 3 squared is 9, 3 times 3, c squared. 64 and 9 is 73. And then you take the square root of 73 and the square root of c squared. Remember, this is the property of equality. Whatever you do to one side, you have to do to the other. Square root of c squared is c. And then this is just the square root of 73. Please do not change that to a decimal. That will be incorrect. Now, we've come over here for our trigonometric functions. We've got sine of theta is opposite over hypotenuse. Well, we know opposite is 3 because it's directly opposite the hypotenuse. And we know that c, or the hypotenuse, is the square root of 73. Let's actually write that in this. So the hypotenuse is the square root of 73. And the adjacent is 8 over the hypotenuse, which is the square root of 73. And then the opposite is 3, and the adjacent is 8. This one's finished. Please do not change it to a decimal. Leave it as a ratio. All right, these are not okay because you've got, this is where your problem lies, is you've got this radical symbol in the denominator. So you have to get rid of it. Well, how do you get rid of it? We go back to what we learned previously. You're going to multiply that square root of 73 by another square root of 73 to get 73. Whatever you do to the denominator, you must also do to the numerator. So it's 3 times the square root of 73 over 73. 3 and 73 have no common factor other than 1, so that's how you leave it. Okay, we go back over here. You can't have the square root of 73 in the denominator, so you have to rationalize the denominator. Square root of 73 times the square root of 73 is 73. Whatever you do to the numerator, based on your, you must also do to, whatever you do to the denominator, you must also do to the numerator. So it's 8 times the square root of 73 over 73. And again, 8 and 73 cannot be simplified any further. So this is your final answer for your cosine. So sine is 3 times the square root of 73 over 73. Cosine is 8 times the square root of 73 over 73, and tangent is 3 over 8. Again, you could put them in the calculator and get a decimal, but that's not what we're looking for. So please leave your ratios as ratios. Do not convert them to decimals. We'll be moving into at least 3 recordings for chapter 12.1. This is a pre-12.1 look at. This is pre-12.1 look at what we're going to be doing with right triangle trigonometric functions.